This is Unit 3, Lesson 3, Rotations on the Coordinate Plane. This will be the lesson video. So again, we're on the coordinate plane, so we have those x and y axes and the grid to work with. And a rotation that they tell you the rule for, or that we're writing a rule for, will have a capital R. Remember, reflection is lowercase r, rotation is a capital R. And anytime you're referring to a rotation, you must include the center of rotation, which is a point. This is regardless of whether you are on the coordinate plane or off of the coordinate plane. We have to tell you about what point are we rotating. Since it's on the coordinate plane, we need to indicate an amount, right? 90 degrees, 180 degrees, 270 degrees. And you can either state whether it is traveling clockwise or counterclockwise, which indicate positive or negative. So keep in mind that counterclockwise, which goes against the direction that a clock normally travels, and there's a clock in every room, so you can always look at one, that is considered the positive direction, and clockwise is considered the negative direction. Why is that? Well, in geometry, in math, on the coordinate plane, quadrant 1 is over here, right? So when we start our angle, we're starting on the x-axis, and then we're opening it into the other quadrants. So quadrant 1 is here, quadrant 2, quadrant 3, and quadrant 4. And so that is why counterclockwise is considered positive and clockwise is considered negative. Again, it goes in the order of the quadrants. Okay. So again, when you're indicating, you can say this was rotated 90 degrees about the origin counterclockwise instead of saying positive or negative. Or you can say this was rotated 270 degrees clockwise, again, instead of stating positive or negative. But you do need to know how to identify which way you're supposed to be rotating about the origin. So if it's positive, counterclockwise, again, in the order of the quadrants. So a rotation that is performed 90 degrees clockwise, well, that would and we're going to say that these are about the origin, so there's my little O. That would be negative 90. Well, that is the same as rotating 270 degrees counterclockwise. So they will end up in the same place. We call those coterminal. You do not need to know that term. So R, 0, 270. So again, counterclockwise is positive. Rotating 180, that's going to give us the same location regardless of which direction we go, which is awesome. So the rotation about the origin, a negative 180 degrees, will give us the same result as a 180 degree rotation counterclockwise about the origin. So again, capital R, subscript O for origin. Again, that's the point in which I'm rotating about, 180. And again, these are the rules. I can write them in words. I can write them using symbols. So a rotation 270 degrees clockwise about the origin would be negative 270. That is equivalent to a 90 degree counterclockwise rotation about the origin. Again, capital R, lowercase o for origin, the point or center of rotation, 90 degrees. So below, I gave you some examples of what it looks like. What does it really mean when we're rotating? We're keeping that angle between the pre-image point and the image point at 90 or at 180 or at 270. Again, this would be our negative 90 or 90 in the opposite direction here. And again, these are all rotated about the origin, which is our center of rotation. The center of the grid, 0, 0, is our center of rotation. Okay, so that's the first part of the lesson. We're going to go over the rules for rotation, and I'm going to show you a couple ways that you can do that without memorizing them, so I'm going to do that in the next video.